Here we go with Unit 1, Lesson 4, and we are going to focus on operations with radicals. So think back to like when you first learned about PEMDAS, right? PEMDAS is order of operations. Operations in math means addition, subtraction, multiplication, and division. So in lesson 3, we talked about how to simplify individual radicals, individual square roots. But now we're going to look at how do I combine different square roots together based on whether I'm adding, subtracting, multiplying, or dividing. Now, addition and subtraction of roots, you basically are going to think of it like combining like terms. Combining like terms. So, for example, and here's what I want you to think about. If I have x plus x makes 2x. So, square root of 5 plus the square root of 5 is 2 square roots of 5. It does not become square root of 10. If I have the square root of 5 plus another square root of 5, it's 2 square roots of 5. So, for example, if I have 3 square roots of 7 plus 2 square roots of 7, that gives me 5 square roots of 7. 9 square roots of 6 minus square root of 6, well, that's really a 1. So that would give me 8 square roots of 6. 12 square roots of 15 plus 6 square roots of 15 gives me 18 square roots of 15. Okay? So when you're adding and subtracting radicals, adding and subtracting square roots, you have to think of it like you're combining like terms. And just like when we're combining like terms, there's only certain things that I can add together, right? I can't do x plus y. I can't do x plus x squared. So in the same way, we can only add or subtract radicals if the same number is under the radical, under the square root. So we have to look for basically like terms. So example 4, what can I combine with 3 square roots of 5? Do I have any other square roots of 5? Yes. 3 square roots of 5 and 6 square roots of 5 is 9 square roots of 5. Then I look and I see, okay, I have 4 square roots of 2 minus 2 square roots of 2. That gives me 2 square roots of 2. And I cannot combine these together by addition because they have different numbers under the radical. All right, you try number 5 real quick. So pause the video, give number 5 a try. All right, hopefully that went well for you. You should have gotten 4 square roots of 3 plus 9 square roots of 10. All right, moving on to example 6. Here, just like always, I'm going to distribute. So 2 times the square root of 5 gives me 2 square roots of 5 minus 2 square roots of 3. Here I'm going to distribute the 3. And just like before, I'm going to combine like terms. So 2 square roots of 5 minus 3 square roots of 5 gives me negative 1 square root of 5. Then I have negative 2 square roots of 3 plus 3 square roots of 3 gives me positive 1 square root of 3. So that would be my final answer there. Let's try the next one. I'm going to distribute the 5. 5 times 3 square roots of 6 gives me 15 square roots of 6 minus 10 square roots of 7. 5 times 2. Now be careful here. This is a negative 4. I'm going to distribute a negative 4. That gives me minus 4 square roots of 7. And when I do negative 4 times negative 2, that gives me plus 8 square roots of 6. And again, I can combine the like radicals together. So 15 plus 8 gives me 23 square roots of 6. Negative 10 and negative 4 gives me negative 14 square roots of 7. All right, moving on. So 2 square roots of 3 plus the square root of 27. Can I add those together right now? No, I can't because there's a different number under the square root. However, in lesson 3, we talked about how to simplify square roots. So 3, I cannot break apart any further because it's just 3 times 1. 27, however, I can break apart. 27 is 9 times 3, and 9 is 3 times 3. So remember, we're looking for pairs. So I have a pair of 3s, and I have a loner 3. Remember, you only get to go outside if you have a friend. So I still have this 2 square roots of 3 right here. Plus, square root of 27 is now 3 square roots of 3. And hey, look, now I can actually add these together because they are both square roots of 3. So 2 square roots of 3 plus 3 square roots of 3 gives me 5 square roots of 3. All right, example 9. Square root of 8 plus square root of 18. Same idea, but we got to check. Can I break apart 8? Yes, I can. 8 is 4 times 2, and 4 is 2 times 2. So I have a pair of 2s, and I have a loner 2, which gives me 2 square roots of 2. 18. Remember, there's lots of ways we can break this apart. You could do 6 and 3 or 9 and 2. It doesn't matter which one you choose. You should end up with the same numbers at the end. I'm going to do 9 and 2. And 9 becomes 3 and 3. But like I said, either way, you should end up with a pair of 3s and a loner 2. You get to go outside if you have a friend. So 3 goes on the outside, 2 stays on the inside. And now they are both square roots of 2. So this becomes 5 square roots of 2. Okay. Example 10. It's the same idea, and I would like you to try doing example 10 on your own. So pause the video and give this one a try and check back to see how you did. All right, so if we break apart 12, that gives me a pair of 2s and a loner 3. So I'm going to have 4 times 2 times the square root of 3, which gives me 8 square roots of 3. 75, I always think about quarters, like actual money, coins. 75 cents is 3 quarters, so 25 times 3 gives me 75. And 25 is 5 times 5, so I have a 5 gets to come to the outside, 3 stays on the inside. And if I do 8 square roots of 3 minus 5 square roots of 3, that gives me 3 square roots of 3. All right, moving on to multiplication. And what you have to remember is that the rules for adding and subtracting are different than the rules for multiplying and dividing. So just like, let me find a scrap piece of paper here. Just like, I want you to think about this. If I have 4x times 5x squared, I can multiply these together. I do 4 times 5 and get 20. X times x squared gives me x cubed. However, if I do 4x plus 5x squared, there's nothing I can do to combine these together because they are not like terms. And guys, the same rule applies for square roots. The same rule applies for radicals. So Like, for example, if I have the square root of 3 plus the square root of 5, we just talked about how we cannot combine those together by addition. However, if I am multiplying them together, now it's a new operation, and we're going to treat them differently. And when we're multiplying, we can actually combine them together, and it does become the square root of 15, just like you think it would. Okay? So it's really important that you remember that the rules for adding and subtracting are different than the rules for multiplying, and then later on when we talk about dividing as well. So, keeping that in mind, let's take a look back at our examples here. So, just like I said, square root of 6 times the square root of 3. I would not be able to do the square root of 6 plus the square root of 3, but I can do the square root of 6 times the square root of 3. And that gives me the square root of 18. Now, we always have to check. Can we simplify it? Can we break it apart? And the answer is yes. 18 is 9 times 2, and 9 is 3 times 3. So I have a pair of 3's and a loner 2. Remember, you get to go outside if you have a friend. So this simplifies to 3 square roots of 2. All right. Example 12, 3 square roots of 2 times 4 square roots of 6. Here's the rule. We go inside with inside and outside with outside. So what does that mean? That means I'm going to do 3 times 4, the outside with the outside, and 2 times 6, the inside with the inside. 12 times the square root of 12. And again, we always have to check, can we simplify it? The answer is yes. It's not a perfect square, but we can break it apart. 12 is 4 times 3, and 4 goes into 2 times 2. So I have 12 times 2 times the square root of 3, which gives me 24 square root of 3. All right, I'm going to skip down to example 14. I can multiply these together. 8 times 1/2, this gives me 8 times 1/2 is 4. Can I simplify the square root of 4? Yes, it's a perfect square. So the square root of 4 is just 2. No more square roots. Nothing left inside. All right, I would like you to try example 13, 15, and 16. So pause the video and give those 3 a try for me, please. All right, so square root of 8 times the square root of 5 gives me the square root of 40, which you can break apart into 2 square roots of 10. Example 15, we get 6 times the square root of 450. And if you had trouble with this one, remember that any number that ends in 0, we can divide by 10. So I broke it apart into 45 and 10, which those are numbers that you should hopefully be able to find factors of. We break it apart. We have a pair of 5s, we have a pair of 3s, and a loner 2. So I have the 6 that was already out there, and then the 3 and the 5, which if you multiply that together gives you 90 square roots of 2. For the last one, we have 36 times the square root of 36. Now, 36 is a perfect square, and the square root of 36 is 6. So we're just left with 36 times 6, which is 216. All right, that is it for this video. We'll see you for the next part of the Lesson 4 notes.